Wait, did anybody see that? Did you see how the tennis racket flipped? Let's take another look. If you look closely, you can see the racket flips the way you'd expect it to rotate out of my hand, but then it does a half flip over as well. What is this? Well, it's known as the Janet-Beckov effect, the intermediate axis theorem, or more commonly known as tennis racket theorem. So, how does this work? So let's explore what makes this possible, of course, with a tennis racket. But first, let's understand the physics behind this. The tennis racket theorem states that the motion of the racket is influenced by its moment of inertia, the axis around which it rotates, and its angular momentum. Angular momentum describes the rotational motion of an object. It depends on the object's moment of inertia and its angular velocity, which is the rate at which it rotates. The moment of inertia refers to an object's resistance to changes in rotational motion. It depends on the distribution of mass and its distance from the axis of rotation. In simpler terms, while an object is spinning, its mass gets evenly distributed away from the axis of rotation. And the axis of rotation is the line around which an object rotates. And because of this, tennis rackets have 3 axes of rotation. For the first axis, it's easiest to spin the racket around the first axis because the mass of the racket is spread out closer to this axis than the others. Its moment of inertia is the smallest when the racket is spun about this axis. Spinning about the third axis has the greatest moment of inertia. It spins slowly as compared to the others because the mass is distributed the farthest away from this axis. Spins about the first and third axes are stable and balanced. When rotating about either of these axes, the racket only rotates on that specific axis. No other rotation is occurring on any other axis. Rotating about the second axis, the intermediate axis, where the moment of inertia is between the other two, creates an unstable rotation. A half twist begins and there's essentially nothing you can do to stop it. What's great about this principle is that it can be replicated with a variety of household objects, such as cereal boxes, cell phones, you name it. What makes the Janet-Beckov effect possible is flipping an object with 3 distinct axes of rotation on its intermediate axis.